Can I see how many people are there?
Yes, you can see it on the eye icon in the top left corner of your screen. So as of now, none of the person has joined. So we can see zero views in that. So let's wait for a minute and then we can actually start.
Okay. Just
Hello everyone. Thanks for joining. I am Dipali Gulshrestha on behalf of AWS user NCR community. I would like to welcome you all for today's session on creating blockchain on AWS. This session will be delivered by Anuj Agrawal. Before we start, I would like to cover a few admin bits. Like after the webinar, recording will be available for you to refer on our YouTube channel. And the link for the slides will also be shared in the end of session. And as you go along with the webinar, if you have any questions, you can type them in the chat box option on your screen. We will allocate some time to address your question at the end. Now let me quickly introduce you to our speaker, Anuj Agrawal. Anuj is a technologist and he is founder of I8 Labs. He has worked on strategic initiatives for blockchain-based trade and lending solutions. He acts as a fintech enabler and blockchain SME. Now I'm handing it over to Anuj to share his learnings and experience with this community. I hope you will enjoy this session. Over to you, Anuj.
hi guys, how are you? So thanks for coming. Thanks for investing your 2 hours for the session. Great. And without much ado, let me just start with the learning. And I want this to be more interactive, so keep on asking questions. Uh, just one question, and as it means obviously you have joined. So, how many of you have actually worked on blockchain? Because the topic again, I means maybe can structure it more into the blockchain, how to use on the AWS, or if you have not never ever used blockchain or never worked on it, then I will maybe uh, start with the basics of the blockchain, and then we'll take you a deep dive into how you can start your first project or your first setup on AWS. So just maybe put it like yes or no. If you have worked on it on blockchain, uh, then type yes or in the comments box. If you have never worked on it, then I will just maybe take it slow and we'll talk about the blockchain first and then we'll take you through the okay. So I got couple never worked on Ethereum. Uh, Sorry, will not be talking about Ethereum. Yes, but great because currently Ethereum is not live on managed blockchain on AWS. Okay, so I think most of you have never worked on blockchain. So I think before we actually jump into a deep dive into the programming of the blockchain, I think it's would be of interest to understand what blockchain and how it fundamentally change how we think or process or what we call as like a trustless system. So let me start with my presentation. Okay, let me just share my pack. Okay, guys. Okay, so feel free who wants to join me, just scan this and join me on a LinkedIn. Uh, Happy to connect with the community on the blockchain or AWS. So just maybe an intro of what we do as I8 Labs. So we're a product design and digital transformation. We also offer and support services to startups in terms of CTO consulting. Primarily, we are into blockchain space, and we have our own solution on province and asset tracking and rapid prototyping, which is our partner products where, as an innovation lab and a fintech lab. We are based both in UK and India, and planning to go to US. Okay, so yeah, so this is what we're gonna start. So okay, guys, the thing is I can't see your question. Okay, so guys, this is what we're going to talk about: blockchain and smart contracts, cryptography, and we'll talk about your doubts. Most probably, it will not happen. So I will start from the very basic and try to connect with the real world, then to talk about the jargons of the blockchain.
So, Amit,
Okay,
sorry to interrupt. The video that you just played, does it have audio as well? Because we could not
no,
hear.
no,
Okay,
doesn't have the audio. Yeah.
sure, fair.
Okay, but yeah, before I like maybe talk about what, so just a brief intro. So I have like 18 years of experience. So I was like heading and part of the RBS group for almost 10 years. Before that, I worked in Citibank in US, and then may I work for TCS. So I like throughout my 17 years, I worked in financial industry uh, and built systems and worked on blockchain products. So I just give you a brief idea uh, where my journey started with the blockchain and why I am here. I am speaking. So and to be honest, okay, so not too intelligent or not really techy, because I tell you a story. I brought my first blockchain, or for sorry, for my first Bitcoin in 2012. Okay, so and the price at that point of time was $21. So at that point of time, I was in US, so I brought a. Uh, I heard about it. I was reading about it, and said, okay, let's buy for maybe $200 and buy some bitcoins. Uh, whoa! So and the current price is this much. So you can say how much money I've made. But the reality is, as like being a techie, I was not so I was not aware how things works. So I just went to the site, I brought it, and then it's done. But I have no idea the cryptography, what is the wallets, and how those keys are saved. So in 2013 or 14, I think my laptop crashed, and all the keys and everything, I just put it on the downloaded on the laptop, and everything gone for a toss. And with Bitcoin, there is no help or support where you can give a call and say, okay, so forgot my password. Can you reset it? That doesn't happen. So now somewhere on the chain, my few of my bitcoins would be lying with the dangling pointers. So because there's no owner to those, or there are the owners, but I can't claim that. So that's why here I am. If I have those Bitcoin, I would be in Hawaii and enjoying my life. So that's my journey of, and but yeah, that's something and that's where it intrigued me to understand more how Bitcoin works and how blockchain works. So that's the journey I've gone through. Okay, let me just hide this. So let me just talk about the real world. So if you look into the real world, how the business network work is, and think about any business trade or anything. So actually, when you just simplify any trade, it's a combination of participants, an asset, and a contract. So you talk about equities. So the assets are the participants is a seller and a buyer. So if you want to buy, if you're talking about a secondary market, if you're talking about a primary market, then an issuer and the subscriber. One side the asset is the equities and the another is the cash. So cash is also an equity, and there is a contract which says at what price and who is buying it. Maybe you talk about your home loan. So the one is the home and the another is the money, and there is a contract uh, with the bank that okay, you are taking this loan and you must pay this particular interest to me. So that's every if you look into it, every transaction can be actually, when you try to simplify it, is actually has participants assets on both sides which exchange, and the terms of the exchange is a contract. Okay, and these things can be fulfilled by a blockchain network. So currently what happens is in the network, uh, to enable these kind of transaction, there comes the middlemen, which is trust builders. So you can actually call them as banks, financial institutions, uh, delivery. So you talk like Amazon. It's again like, okay, buyer and a seller, and in between there's an Amazon which brings in the trust and factor for that transaction or for that deal to happen. So then there comes the uh, participants who are not a participant of the deal, but they are there, which enriches or bring trust onto this network. And with blockchain, we say, okay, can we just move those participants or market makers out of the chain? So that's where blockchain comes in. I think that is clear to every one of you. I just need to go to back. Uh, okay, fine. So let me, if you have any question, because I can't see your screen. So if you have any question, I will be coming back and looking at it and responding. Okay. So let's talk about blockchain. So how people describe it is a distributed. So it's an open distributed ledger that can record transactions. So it's like distributed. So you must have worked on the distributed databases. Now the data is across the nodes. We'll talk about what nodes are as we progress. It's programmable. So all data is programmed. So you don't have to actually, once you call an API and set the data on one of the node, then automatically it's actually published on different nodes. Yeah, means if you have few people must have actually worked on few of the platform. So we'll talk about whether it's get broadcasted or will be just shared across two or three nodes. That's a different kind of a setup, but in a purest form, any information change on a node will be broadcasted across. It's decentralized. So there is no central control on a blockchain network. So everything is decentralized. All nodes have the same power or the same say in the network. That's why we call it like peer-to-peer network. Cryptographically, so it uses a hash function and a public and a private key encryption. So if you look into it, these cryptographic concepts are not new. So these are like as old as like maybe a decade old concepts. All your torrent and other things are primarily peer-to-peer network, and uh, I would say all your certificates are encrypted by these public and private key encryptions. Okay, so if you want to learn about it, the cryptography, so these are like two cryptographic model which I used is hashing of a function. So what primarily hash does it like, so whatever be the number of data, once you pass into the hash function, it will give you a fixed length string, and this is non-deterministic. So from the length, you cannot figure it out what the data was. So the only way to validate is you get the data again, and you convert the hash function for that. And if you matches both the string, that means the data is same, but you cannot reverse it back. So this is like a non-deterministic encryption which is used in this, and that what makes blockchain secure and unique in terms of moving data and validating in such a small and quick time. Tamper proof, because this is like all the ledgers are linked to the previous chain. This is kind of a link node. That's why this is tamper proof. And as I just talked about it, the how the cryptographically it is saved. that the hash of a previous block is used for creating the hash of the new block. So that means it's like a linked list, and all the links are connected to each other and chronologically arranged. So it is like all the blocks are timestamp, and as and when it comes to the network, those are linked to the one single blockchain, and that's why it is called as a uh, chain of a blocks, which is like cryptographically sealed, which you can't open or you can't change. Okay, so that's what in a nutshell blockchain. Let me just talk about. So this is I advise each one of you who are like new to blockchain, read this paper. This is the Bitcoin. It's available on bitcoin.org. Bitcoin. It's not, I would say, primarily written in a cryptic technology language. It is so basically written in an English language and explains the core concept of Bitcoin and peer-to-peer network. Beautifully written. I suggest each one of you just read it once. Okay, and this is published in 2007. Okay, fine. So one thing I just maybe interest of the time, yeah, your time check, uh, guys. Just yeah. Okay, sorry. Okay, one question, Mayank. Bitcoin, Ripple are on the same theory. Uh, Yes, this is on the same theory in terms of the blockchain, but how each and every platform manages it or actually code this is different. So I will take the question, but let me just go through create a kind of why in 2007 and why blockchain or Bitcoin is so special and different. So if you look into it, blockchain is or Bitcoin is a solution to a problem. Can someone say, okay, what happened in 2007? Why someone having a beer on a maybe in an evening thought of creating a blockchain kind of system in 2008? Because this is not coming from an academia or some research. This is coming out of people who are actually sitting in there and solving a problem, and that's why they created a blockchain or a Bitcoin. Anyone, any idea? So this is a people movement, if I say so, Bitcoin. And okay, fine. Let me just go through. Okay, so what happened in 2007 was uh, market crash. Okay, this was subprime mortgages, which means you start losing money because of a fraud in the market where subprime. So subprime are the people who are actually uh, tagged by the banks that they cannot pay the cannot get the loans. So what happened is like those people were, because they were marked as a prime, so those people were giving loan at a higher price. So it's like, so they can't pay. If a bank will give a loan and the interest is at 5%, then they cannot, bank identifies that these people are not good enough that they will return that 5% of the interest. But then what was done is uh, they were given the loan at 10%, and those securities were like subprime mortgages were actually uh, packed. So someone who cannot pay 5% was given a loan at 10%, assuming that they will pay. So this is how the subprime mortgages happened in 2007, which means banks and financial institutions and governments has to actually bail them out, which is the taxpayers money going into saving the economy, which means your hard earned money is, the value of that is going down because there is less liquidity in the market. And that's where someone has taken that, okay, I just want to take a control where these trusted parties are not trusted anymore. And I think that was the driving point for someone to build a blockchain like system in 2008. Okay, these are some of the uh, reports which were there and how people actually uh, say about blockchain. So blockchain is kind of the next revolution and internet, so which will bring value of transfer onto the market. So there is a lot of noise, but there are a lot of good products coming on. So what is blockchain? Blockchain is a technology which drives Bitcoin. So to bring a decentralized structure or a Bitcoin or a cryptocurrency, uh, those people build a platform or a technology or a system which we call as blockchain, and we are now using the same and the if you want to create your own coin or something, the Bitcoin code is there on the GitHub. You can directly go and fork it and just maybe change few fields, and then you can launch your own cryptocurrency with your name. So I can launch it with my name as Anuj, and I don't know is will there any buyers or it or not, but yes, it's pretty simple to launch it. But if you feel that okay, you can use that, because what is in simple sense, it's a digital asset. Now if you convert it to a dollar, then it becomes a cryptocurrency. If you convert it to a asset as a property, then it will be a different tool. If you can convert it or link it with your car, then it will be your asset will become a car, the currency will become a car currency or car token. So that's what we currently now talk about is a tokenization of an economy. So in future, what will be happen, and that's what currently we are working is like you can own a property instead of all on a blockchain. So if there is a car or there is an apartment, you can part own it, maybe 10%, 2%, 3% in terms of the number of uh, tokens you buy, and any revenue that will come onto it will be distributed in terms of the number of token you have. So it's equivalent to the equity model, wherein you buy an equity in the company. Now if a company generates some revenue, then that equity can be shared on to the equity holders in that ratio. So but yes, now this is possible with blockchain at a micro level. Okay, so let's look into maybe yeah, what is blockchain made of. So I talked about it. So blockchain is made of a peer-to-peer. Okay, so this is not something which is a new technology. All torrents, downloads, which were there, are primarily peer-to-peer systems. Okay, so is it something invented for blockchain or new? No. Cryptography, which is like hashing of a function or private and public key. That cryptography is used for ages. I think a lot of people must have used digital signs, so those are also cryptographically secured. And consensus. So consensus is not again a new topic. Consensus is like whenever we go for a meeting and we look for a consensus where participants or the member agrees on what is right. So there is no in a pure blockchain, there is no thing as like this is the right transaction. It's based on the consensus of the network. Yeah, in a private blockchain or a consortium based blockchain platform, the consensus part is handled differently. But in a public blockchain, it's primarily uh, all the participants are treated equally, and generally it's 51%. If agrees to a particular change or a particular transaction, then that is the final on the network. Okay, in a private blockchain, consensus is not there for the simple reason you know who are the participants. Okay, so let's me explain in a very simple way what blockchain. Uh, if one question to Are you clear how blockchain works? Then I will skip it. But if you still like exactly how blockchain brings benefit in terms of cost saving for the financial institution, then I will go through it. Please comment uh, J if you want to go through it. Otherwise, I will skip this session, this part of it, and move on to the demo of the blockchain and smart contracts. So, just waiting for your comments on the comment box. I'm just uh, I don't see any comments. So type J if you want. Otherwise, I will just skip to the next part. If you understand how many people I can't see. E- Uh, I don't see. I don't know. Should I? Okay, I think couple of J's onto it. So let me just maybe walk through this. Okay, so these are like really good friends. So I think everyone must have known. So Jay, Viro, and Gabbar are close friends. After the Chole got over, they went out for a party. Though Sholay was a flop movie, but still, yeah. After all those dialogue baji, they actually went out for a party. Now, as three friends go to our party, what happens? Do you actually say, okay, we are buying a pizza? Then everyone, okay, if it's like maybe 100 rupees, everyone pay 33 rupees and 33 paisa, or you say, okay, someone will pay 100 rupees, and the next time, if there is anything, another person will buy. Do you settle and do you like, okay, split it at that point of time, or you split it later on? I think most of the people will split it this way. Okay, so first transaction is done by maybe Gabbar or maybe Jay. So this is how the ledgers for each and every one. So this is if you look into it, if you three friends goes out, this is like simplest form of you can keep it in your mind. But again, this is a simple ledger you keep. So one transaction is done by a transaction of 500. 1500 is done by J. So that means from Gabbar to J, 500 needs to be paid. Okay, Viru will also pay J 500. Okay, so that's why for that particular 1500, uh, both Gabbar and Viru will pay to J. So this is one transaction entry. Now, suppose maybe uh, J again spent 100 rupees, maybe for a or 300 rupees. So which means Viru will pay to J and Jay will pay to Viru 100 rupees, and then maybe Gabbar has paid for uh, a night out where he paid maybe 3000 rupees. Then again, both everyone will make an entry that okay, Jay will pay to Gabbar 1000 rupees and Viru will pay to Gabbar 1000 rupees. So this is kind of a simplest form of ledger you keep among three friends. Okay, and then what happens? You actually net those out and settle. Means you might not be writing those exactly the way I have written. Maybe it's in your mind, but that's exactly what is happening on a smaller scale. But when you go onto the larger scale, this is what happens when a transactions happen across the banks. This is how um, when a customer of one bank make a payment to another, this is how the ledgers are made. Or one transaction has happened, both the parties keeps their ledgers. Okay, so this is the simplest form of ledger among friends. Now what happens is, now you say how many transactions are happening. Four. So what happened? There are three transactions, but in a ledgers, because Jay, Viru, and Gabbar has kept it. It's like 1, 2, 3, 4, 4, and 12. So there are like 12 transactions are done in different systems. Obviously, it's separate, but actually the number of transactions between these three people happened is only three. So you can see in every transaction there is a cost associated to it, which means uh, it's a costly affair. Okay. So what you can do is, if you are three friends, you say, okay, we can keep, and if you are staying together, uh, then you can say, okay, in one room we will keep a single ledger, which is a single notebook, where anyone who spent the money will make an entry. Okay. So this Jay will make an entry that, okay, Gabbar will pay to Jay, Viru will pay to Jay, Viru will pay to Gabbar. So now these entries are made by Gabbar, and Viru made an entry. So now this is something a single ledger, which is kept is a notebook which is kept in the common room, where everyone makes an entry. And then you can like, okay, so now out of 12, how many entries are there? 6 entries. So once you have a single ledger, uh, the number of transactions has reduced significantly, which means every transaction is a cost, uh, reduces significantly. And what currently I'm talking about is the individual transaction. Now what happens is, maybe there is some wrong entry in a Jez ledger, then there will be a dispute. So Jay might say, okay, no, Gabbar, I just have to pay you 500. Then Gabbar will say, okay, no, you remember I paid at that day when you were actually doing this. This is the bill. And then we'll bring in the Viru also to say, Viru, you were also there uh, on that day. You remember I paid it. This is how the common dispute settlement activity. And maybe Jay will agree or Jay will not agree. And then finally you will agree, okay, I will pay not uh, 500 more, but let's agree, I don't remember, I don't agree, but if you are saying and you have something to prove, then let's agree on 250. So that's how the dispute settlement process. So you can understand when the dispute settlement is a very costly affair. So Viru will come in Gabbar, and there will be a lot of negotiation and discussions, and proof sharing will happen, and then finally a dispute. So either Jay will pay 500 rupees or extra, or he will pay 250. Got it? This is how many people actually just say yes onto the comment box, settle their individual transaction with their friends this way. Anyone? Guys, why I'm asking you a question? Because I just want to that, okay, we are on the right track and you are understanding. Uh, Otherwise, I can just continue. Okay.
So
Fine.
Anuj, there is little lag when people are responding via YouTube. So that's how you are seeing a response a little late. But yes, I think
Okay.
it's better to continue.
Okay. Fine. Sure. Fine, guys. So now this is done. Now what happened is, you agreed this is a great way. You reduce the number of transactions. Okay. How much each one has to pay. Okay. This is done. But now, maybe at 2 o'clock, Gabbar being a Gabbar, he might walk down slowly and make an entry. So instead of, he will put an entry which says Jay needs to pay to Gabbar 5,000. Will it be a legitimate entry? Because yes, it's a so maybe next week if you try to settle, then you will see, okay, this much I have to pay, and then Jay will have a shock of his life. I need to pay 5,000 to Gabbar. And I think then I think that was the reason why Jay and Gabbar are enemies. From there, I think the enmity started, and he keeps on asking from Samba to bring Jay. Okay, So now this is a challenge. Now how you solve this challenge? Okay, you actually put, so one thing in a ledger, there is only one thing you put it. The person who has to pay will make an entry. So now Gabbar has to pay to Jay 500. He signs, and Viru has to pay to Jay, then Viru will sign. Okay, so you cannot sign, you cannot actually transfer something which you don't own. It's like, and if you look into physical world, this is exact, and this is how primarily all the blockchain process works. So when you actually transfer one asset to another, you cannot go and say, give that asset to me. The owner of at that point of time asset needs to transfer the asset to the next participant until unless you cannot actually request for an asset. So and then Viru will sign it. Now here, if Viru needs to pay, he will not put a wrong amount and his signatures are there. So he might say that, okay, I will pay a less amount to Gabbar, but that can be validated, but it can't be having a entry where Jay will say, Jay will pay to Gabbar 10,000. So those things will not be there. So it's like exactly if you look into, it's a check. So when you write your checkbook, so it says, because you own the money, you write it to whom you want to pay, how much you want to pay, and you put as your signature. So that same physical process is now on a digital system. Now in digital system, how you do a signature is via digital signatures, which is a public private cryptography, where you actually sign the transaction and then via private key and then share the public key so that other person can actually view the transaction but cannot amend it. So he can accept the transaction. So if he reduce the number, then Viru can accept the transaction, whether it's 1000 or 500, but he cannot tamper with the transaction. So this is uh, a very simple form of a transaction on a blockchain, which mimics the real world scenario. So means if you are interested, you can actually read my blog on my LinkedIn, which is blockchain, old process in a new model. So so this is like what we used to do in a physical world that is now made possible to happen uh, on a real world, I would say, on a digital world. Okay. And now the next step is, which is the distribution. So you distribute these copies like in a simple way, all these signature, and then you click on and send it to for everyone on a WhatsApp group. So if you three of your friends have created a group, you make an entry, sign it, and you just click the photograph. Now everyone has the same copy of a ledger, which is signed and secure. Now you cannot make a change. So this is, I would say, most simplest way to understand the flow of a blockchain. Primarily flow of a public blockchain. Now you talk about how the blockchains are secured. So what blockchains are secured? So these are like how you do it. So again, I will try to connect it with the real world. So when you have a notebook written and you now agree on a single ledger, which is a notebook kept in the main room, and everyone signs it, then every end of the week or every 2 week or every month, you actually do the netting where you say, okay, this page is done, this much is Jay has to pay, this much Gabbar, this much Viru has to pay to each other, and then you say this is the netting, and you just mark cross on the notebook. That means this is closed. So there can't be any previous entry onto the previous block. Now, in digital world, that thing is not possible. So what do? You actually take those maybe 15, 20, 30, means when in Bitcoin we talk about million of transactions. You actually create the block and then you find the hash of that block. Oops, sorry guys. Uh, so this is the hash of this block. Now what happens is, now the next block is get attached, because when I talked about the hash function, so now you have these 6 transactions, and this has one more entry which is the hash of a previous block, and then the hash of this block, and then on top of it you actually do the hashing of the complete block, and this way all blocks are linked. Now what happens if I make the change the entry in any of the previous block? Currently this is not running. I can show you the running examples also, but yeah, so if I make an entry, then what will happen, this hash will change. Maybe this will become this, then this will not get linked to it because this is has a previous block. So what happens is you need to either needs to change all the blocks, and if you go and study the hashing function, it requires an enormous number of processing power to generate multiple hash functions to change the blocks. So this will never be linked, and then this tempered block will be identified. So that's why it becomes tamper proof. Okay. So that's why we call, a lot of time we call it a trustless system, because by cryptographically all systems are secured, or all transactions are secured in a blockchain. Okay. Any questions, guys? Before I can take it later. Now the consensus part. Okay, so there is a mechanism to consensus where all the trades which are coming, uh, all the parties validates and checks that trade has actually happened. So there is what we call, if you are from the financial industry, so there is a trade enrichment and trade validation. So does that person, if he is doing a trade, does that person owns that equity or asset to transfer? Has that transfer happened? Is there any other trade happened for the same? Because see, if you have 100 and you transfer, means if A has 100 and he transfer it to B 80, then he cannot have another transaction where he said 50 transferred to C. So because of the timestamp, the consensus system will reject the next transaction. So that's where the consensus part comes in. And that's why there is no right or wrong or a central system which says this transaction is valid. It's the group of it which they validate. All the new transactions comes in to them, and they validate what's there in their previous network. Okay, guys. Now this is what is Bitcoin. Now what happened is, in 2000, I think 15, uh, Ethereum comes in, and it has changed everything because of the simple concept of smart contract. So as we talked about it, for every transaction, there is one thing which is participants, assets, and the contract. Contract, I think everyone must be clear. So when you actually log in onto a website, you actually take any policy, maybe your insurance policy, maybe your term plan, maybe your loan, or you actually take any connection. So you actually get into a contract, and you must have seen that, okay, there is a long contract which at times you don't understand, and when you actually call, you get into a trouble, you call the company, they say, okay, there is something written in the fine prints, and this is, you have actually signed that contract, because contracts are complex, and how other people actually understand it is a bit challenging. Interpretation of the contract could be different from different people. Okay. Now what this smart contract is, smart contract is bringing that contract in a coded language, which makes it clear and concise and executable. Okay. So if something has happened, then you are in your contract, it's written what will happen next because of that. If you have taken a loan, if you what amount you have to pay, if you don't pay, For 10 days, what will happen if you don't pay for 1 year? If you don't, that is automatically get executed, and that becomes a smart contract, which is an executable code uh, written on the blockchain. So this made a lot of things in terms of, and that's what we call auto executing organization, where both the parties agrees on a, I would say, contract. So just to give you an example, uh, so if a let me talk about the COVID, so or maybe insurance industry. So suppose I have taken a contract that for my house, if any natural calamity happens, then the company will pay me. Now, instead of going to and putting a claim and providing, which is a costly affair from my side and from the company, I will say I will go for a company which will give me a smart contract. So I will go into a contract with the company that this much premium I will pay yearly. And if something has happens, so if something has happened, that will get broadcasted from the news or maybe any third party source, which is maybe some registered agencies, which we call oracles for this purpose, which actually provides you the data. And if they say, okay, in that region, a earthquake has occurred, then automatically the company will pay me the, I would say, claim. Or maybe you say, if you go into an equity where you say a put and a call, if or maybe if the price has gone up maybe by beyond 100, then you will pay me this much amount. So instead of going back and submitting and giving a proof which someone agrees or not, but you can have a Bloomberg data where the data is coming in as and when it hits a particular threshold, the contract will automatically execute uh, and take the money from one party and deposit into the another party's account. So these are like auto executing, and you can think the amount of money it can save because these are auto executing uh, codes which doesn't require any human intervention once these are written. And these contract to be uh, I would say enforced, both the parties need to sign digitally as you are doing it. So there is a proof that both the parties have signed it, and if any party wants to change, then both the party again needs to sign it. And if you have a notary system in the system, then a notary which will validate and check the contract also needs to sign that contract, that he agrees that these two parties have actually signed the contract before actually putting onto a blockchain. So this is something which is very revolutionary in terms of, and there is a lot of use cases as part of my company and itself. We are actually working on a couple of solution using the smart contract on Hyperledger and Coda. Okay, so these are some of the use cases or process. So there is no middleman, a lot of saving on because of the smart contract, because no human intervention, you don't have to submit, there is a cost for any process, you know. Code is the law, so it's simple, there is no difference in interpretation. This will happen, so it's like if then else statements. Primarily, if this will happen, you need to do this, so you can understand. And it's very objective in a way, so it's not subjective where the interpretation for people changes. Default backups, so your contract as it's already on the blockchain, so the backup is there. So it's not possible that okay, one central system or something has changed, then you don't have a contract. So again, like if you are storing your own contract, then if your system crashes, then uh, the other party might say, okay, have you actually paid a premium, or have you paid or they can change the contract. But if you don't have the physical copy of the contract, then you need to agree. But here it's there on all the nodes. Avoid manual errors, yes, because there is no manual intervention, it's auto executing, there can't be any errors. Trustless execution, yes, because you actually set the condition when you actually sign a contract, and you say, okay, on what condition this has to be executed. So you don't have to trust the agency when you are actually this is getting executed. It's auto executing once it's been signed. Yeah, there are other things which you can commit it. If the key where the amount has to be there, it's not there, then the contract might fail. Yes, there will, I will say blockchain or smart contract will not say solve all problems. It's not a magic wand where it will solve. So it will solve a lot of things. Uh, but again, if you say, when I say blockchain or smart contract, then it should solve everything and every problem, the answer is definitely no. And yeah, it's auto executing, autonomous, you don't have to execute it. So that's what is smart contracts, and this is something which is really exciting. Sometimes when people talk about blockchain, they just look into distributed nature and cryptography, but they don't actually talk or try to understand a lot of on the smart contract. But this is, I think, is the number one thing which is people or the businesses are going gaga about it. It's a huge cost saver. Uh, so yeah, so there are a lot of blockchains currently in the industry. So there are public blockchains, which are which all anyone can join, and there is no link, so you can join up a uh, Ethereum public or Bitcoin or Ripple, or there are a lot of cryptocurrencies which are there. You can join those blockchain, set up your system, and start running it. So all the nodes are equal in public blockchain. Another is a private and a consortium based. So in private blockchain, the entry or the parties who will join are restricted. So there is a member sign up process, and their physical identities are known in a private blockchain. So in a public blockchain, and that's why you will hear a lot of time bitcoins or other ethereum are in news for the wrong reasons, that okay, the hackers are asking for money in Bitcoin. Because what happens once you sign up, uh, you actually, and this is what happens with me, because when I brought it, I actually got a identity on a blockchain, which is my unique identity. So it's my information which is there where brought it, and then for the blockchain network, there is my hash code, which is my identity. Now you can actually go and see the Bitcoin trades or Ethereum trades online. So you can actually Google it uh, on the blockchain, on the Google, where you actually can see each and every trade which is happening. And that's why there are times where say, okay, this major chunk of blockchain or sorry, Bitcoin has been transferred in the last 3 months or last 6 months or tomorrow or yesterday. A lot of people actually keep a watch on those things because those transactions are public, but the identities of physical identity of those people are not public. So if I do a transaction, if people don't know my hash key or my identity on the blockchain, you cannot figure it out because those hash functions are non-deterministic. You cannot take that hash key and convert it and see who was the actual owner of it. And that's why we call it like anonymous, but public blockchains. So that is like the anonymity part comes into the Bitcoin. And that's why a lot of people talk about it like for all the wrong reasons. You can actually ask people to transfer X amount into this Bitcoin account, and no one can trace who actually is that physical person and where that physical person stays. Okay, so that's a drawback, but yeah, again, that's how it's been built. There is no control on how those are doing because there is no physical identity being linked on those networks. But what happens in a private blockchain is like there is a member system. So there is a layer which is called a membership system. Coda has it, Hyperledger has it, Ethereum Enterprise has it. So all these I would say system do have additional layer which is a membership layer, and the participants or a list of participants you can actually say who will actually take care of the membership. So there is a proper KYC process, and you know who is the member. So when a transaction is happening, their identities are known to other parties and is visible to them. But their trades are not visible outside the network. So those trades are not visible, they are just visible within the consortium or to the participant which are in the network. And that's how it's different, and that's why a lot of people can get confused. It's public, it's private, and there, because you know, if I am doing a transaction, then you don't need to say okay whether it's a right or transaction, because if I am doing a wrong transaction, then you can go back and call me or get a hold of me that Anuj, you are doing a wrong transaction. In a public blockchain, that is not possible. That's why there is a consortium, I would say, concept of consensus, where all the participants agree that whether it's a right transaction or not. But in private blockchain, uh, that's not the case. So they use a cryptography part of it, but they don't use the consensus part, which makes these public blockchains bit slow, because the transaction has to go to all the nodes needs to run the process and then validate it and then send it that okay, and then it actually goes and to the main blockchain. But in a private blockchain, that process is not required. So if I am a legitimate member, then if I am doing a trade, then that's going with my name and other parties agrees to it, and then it goes to it. So it's like which both the parties agrees to, then and the notaries look into whether the contract is right or not, then it goes to the blockchain directly. You don't need to have all the participants agree to or come to a consensus for that transaction. And that's why private blockchain are much faster compared to a public blockchain. Okay, fine. So these are some of the potentials application of blockchain. So digital rights, we talk about a lot of in voting, P2P lending, microfinancing, global payments. So out of these crowdfunding, P2P lending, and title record is something which I'm currently working on. The another thing which we are picking up and working on is I would say uh, kind of a LinkedIn where all your learnings are on a blockchain and verified. So those are the some of the products which we are exploring on the blockchain uh, currently. This is something I love it. Just guys read it. So blockchain solve the problem of manipulation. This is a great. So he is the founder of Ethereum. Okay. Uh, People say they trust Google, Facebook, or their banks, but the rest of the world don't trust organization and corporation that much. I mean, Africa, India, Eastern Europe, or Russia. It's not about the places where people are really rich. Blockchain opportunities are the highest in the countries that haven't reached that level yet. So that's why where you don't have too much trusting parties, and it means as we say there are like okay, the trust there is a huge cost of trust which everyone pays in terms of fees or commissions. So that's where just I'm just giving you hints or start thinking on those lines where blockchain can be used as a use case. And if you want to have any discussion, I'm happily available for you to reach out on any use case study. Okay, now let's talk about blockchain and AWS. So I will take a break for a minute, just have a glass of water. Okay. In the meantime, guys, if you have any questions, I just stop it for a second to just go through the questions. Yeah, Mayank, good one. So I don't know those answer, Mayank, about the story of Basanti, but definitely you can talk about it. Yeah, Samba was killed. That's why Samba is not there. Yeah. Uh, Fine. Fine, guys. Let me just go through. Uh, so, blockchain on AWS. Let me. So, AWS has actually means obviously, if you look into it, most of the people are setting up nodes in previously on cloud. So either it's AWS or Google Cloud. That's where most of the people. But yes, if you look into the 25% more than that set up on AWS. So that's like you create an EC2 instance and you set up the complete node on AWS. But now AWS brought two services which uh, ease your setting up your blockchain network. Okay, so the two services which are Amazon Quantum Ledger Database, which called as QLDB. So this is yeah, a lot of I would say when I talk about it, a lot of blockchain purists will say this is not a blockchain because there is no distribution. Okay, this is fully managed, centralized service. But yeah, here the transactions are can be verified. So this has a like a kind of I will say as like a lot of movies. These are like inspired by blockchain, right? So this is not purest blockchain, but yes, it's all uh, and take inspired by blockchain where all your transactions are uh, stored in a journal and all your changes can be validated because in a lot of use cases and recently we were working on one of the use case and I've provided that on my medium account only day before yesterday. I've documented how we actually picked up Amazon Quantum Ledger for one of our solution because sometimes the need is that okay there is one central party but what is required for a solution that the change cannot be happen and if a change happens then the people who are actually or the who are the stakeholders of that system can verify that no change has been happened or onto the system. That's only the need, but they are not interested to run as node. And just to let you know, running multiple nodes and running a complete blockchain system is a bit of an expensive process. So until unless you stakeholders of a blockchain system are willing to pay, there's no point of creating a blockchain network, and that's where QLDB comes into and saves your. And I see a lot of proven kind of system can be built on QLDB, and we also built it recently. Okay, so this is so what Q how it makes it easy. Uh, it's like your all the changes are immutable as what is there in the blockchain. So it's append only. You cannot alter or delete it. So if any changes happen on any transaction, then you can see who changed it and when you changed it and what was the previous state. And it uses the same process of cryptography hash function uh, to save it onto a ledger. The second good part is it uses a similar language, which is like a SQL like. So if you are familiar with SQL, and this is like if you I tell you, there is a lot of people are moving on to SQL. So there was a time where like no SQL and other thing were popular, but if you look into now, a lot of systems and things are coming where they are making it so that this SQL kind of queries can still run on. RDBMS has actually proven uh, for ages that it works fine, and that's why a lot of other languages are coming and systems are coming in, which are SQL compatible. So you, if you know SQL, then you can still use this. It's still a database, uh, and that helps on rapid prototyping also and quickly build your system or proven system on QLDB. Okay, so let's go to the demo part now. Huh. So I don't know, it's signed up. Uh, let me just sign on this. So we go to Amazon QLDB. I create a ledger. So this is what we call as a ledger in QLDB. So Anuj AWS, not typing BC because of the obvious reasons. So that's why I changed it to blockchain. I know you guys. Okay. So now I just created it. On AWS blockchain. So this is a ledger I've created. Okay. Now I go to get just to maybe for everyone who wants to run it. So ledger is created. Now what I will do is like I will just for the demo purpose because I have a different database where my queries you can create your tables in a same form, but for this demo purpose, so it you actually run the similar kind of so you can actually create run these commands run table commands, but for this demo purpose I will just oops currently that is still not now it's active. uh, Sorry, yeah. So now I just load the sample data and this is what everyone can do it. uh, I'm loading the sample data. Now sample data is loaded. Now I can go to the query editor where I can just say so the sample data is loaded. So these are the tables which are loaded. Okay, fine. So these are like tables which are loaded into the ledger Anuj AWS blockchain. Now this now you can actually query it in a similar fashion uh, as you do it in the SQL. Uh, the other part is now I will talk about is the verification. Now you can actually make any changes uh, onto the ledger as you do. So let me just show you. There is no reset transactions happen. Uh, I will just show you how a transaction get verified on a blockchain. So before that, first let's maybe get a key. For verification, what happens is you need to save the previous state of the blockchain or the QLDB at that point of time, which we call in blockchain in AWS call is digest. So how it works is you actually get the digest. So in business scenarios, what happens? You actually save the digest and when a transaction is made, you actually share it to the participant, which is shared in his maybe your S3 bucket or somewhere. Okay. Now, if he does any transaction and the person wants to validate it, you go to yeah. First, he do a query editor. You run the query. So when you run the query from, you get a ID. So what is the unique ID and the blockchain address for that particular transaction? Okay. So while validating, so now if your use case is to validate whether there is any uh, change happened since maybe I was the owner or if I have sold my product. So you can get the current running ID and the blockchain address, save it into a notepad. So in a real application, you will save it at that point of time directly on the application and use the previously saved digest to validate it. This, these all are accessible via APIs. So now I say, okay, I just want to validate it. I put the blockchain, which address I want to validate it. This is my address of the blockchain. So guys, this is something which is blockchain, which all blockchain creates a blockchain address of an entity. And which ID I want to validate is document is this one. Now I actually compare it with my digest which I have saved previously to validate whether there is any current change happened at this point of time. So this is something you need to think through while creating a use case. Now this is my digest. So for demo purpose, I am just downloaded it. Now I am just validating the same transaction. But in real scenario, what happened, how it works is you actually save the digest at that point of time when a transaction has happened. And maybe in future, when someone wants to sell or someone to want to validate it, he actually get this ID from the QLDB and the person will pass on his digest to say that okay, nothing has been changed or I am the current owner of a product. And the verifier can actually combine these two information to validate it. But that something is how you actually uh, fit in these two processes in your use case. So, but yeah, for a demo purpose, I am. So this validates it. Yeah, when it was changed because currently there's no changes. But yeah, it will just show you the complete list and the proof hash of this particular ID change. So this is how anyone, if you have a central party and you want to build a system which kind of mimic and gives a trustless feature of a blockchain, then QLDB is great. Its uh, cost, maybe I would say 1/50th of a blockchain network or less than that because Amazon consider it as a database and to be a blockchain network. So it's highly, uh, I would say, cost effective. Uh, Fine. So this is one solution. Uh, Fine. The only thing is I just need to, when you create it, just clean it up. Okay, delete. Those who are familiar with this thing, AWS, this is a standard process of to avoid accidental delete. Deleting it because I will delete this one also because I have another copy of this on my production account. Just realized this override. You can actually all call all these means those who are like familiar. So command line interfaces. So means this is for a demo purpose, but actually when you are actually using this for building a use case, you need to directly call the APIs via CLI and use it in your systems. So you need to create a user who has a right to modify QLDB via IAM. So those are the separate bits. I think those who are familiar will understand. But yeah, that is beyond the scope of this demo. Right, coming back to the uh, where is here? Sorry. So yeah, guys. Yes. So QLDB is kind of a blockchain which is centrally controlled. So all the history, because you don't have to maintain it, you cannot append any or modify any record on a QLDB. So there is a journal, means obviously your main table will have the current committed transaction, but okay, so in QLDB, it's just you cannot create a smart contract. See, try to understand, Deepali. So, smart contracts and so those are the features. So, in Hyperledger, we call chain. We use chain code, but smart contract are a concept of specific platforms. What blockchain AWS provides, one is where there is a need of a blockchain kind of system, then you can use QLDB, and where you want to set up your environment on a cloud, then instead of doing via EC2, blockchain AWS provide managed services. So blockchain, AWS doesn't provide its own blockchain where you say, okay, you can create your smart contract and you have a own language and a platform. But it actually facilitate or ensure that you, if someone is building a product on uh, uh, either Hyperledger or Ethereum, they can quickly do it. So anyone who has worked on Hyperledger, so and this is the second product I want to talk about it. But yes, QLDB, you can say it's a blockchain inspired product because there are not too many. Means there is only these are like controlled centrally. Okay. Yes, AWS supports permission blockchain, and that's what the second product I'm going to come uh, and talk about it, which is the managed services. So that is the demo of the QLDB. So yeah, so I started working on Hyperledger maybe three or 4 years back, and at that point of time, still if I look into the Hyperledger, and if anyone of I worked on it, it's written in cryptic technology. I would say technical terms, uh, and setting up an environment took me 2 weeks. I think more than 2 weeks initially. And it was when I able to set up a Hyperledger environment. Uh, it was a big feat for me. I said, okay, now it's time of party because I'm able to set up Hyperledger. So that was the times where it becomes so challenging to set up Hyperledger because the only options were you go to the free Hyperledger, download it, and go the documentation step by step, which is so cryptic that it takes ages for me to understand it. The other option is use IBM uh, Blue account. Yeah, I think at that point of time they call it Blue, uh, which is their area or their cloud offering. But for them to use Hyperledger, the minimum cost is $1,000 or £1,000. Now, for someone who is just trying to learn or trying to practice it or to explore it, that's not worth. So I tried the hard way out to set up. Ethereum at that point out doesn't have a enterprise version. The only thing was you connect to the testnet and run few of the commands, and you means there are like few commands which are already given on the Ethereum side. You can just maybe do one or two transaction, create a system of voting or a transfer of assets. So for which the code and everything is already provided by Ethereum, and beyond that, I don't think so. You can do much about it. You can actually have a truffle and run few commands on the Ethereum network uh, on a test net. And if you try to go onto the main net, then it was a costly affair because you have to pay uh, the charges, which is like you need to buy the gas to for the transaction to be committed on the Ethereum. So those were like I would say dark ages of or a tough ages of blockchain. But now uh, Amazon made it really simple for people who wants to who are building systems on Hyperledger. So again, guys, and I saw a few of the question. So this session is primarily not about Hyperledger, but how you actually can run your systems or your network on Amazon. So this is like okay, uh, setting up EC2 or an environment to run your Java code. But I will not means be talking about the chain code and how to set up the running a smart contract on a Hyperledger because that doesn't changes whether you are doing it on Amazon or on your system or you are running on any other cloud, uh, whatever it is. But yes, Amazon made it really simple to do that and to manage it. So this is what picked it up. So this is how the structure is. So Hyperledger Fabric ordering service. This is runs whether irrespective whether you are on a AWS or not. So you have a for every member who is part of the Hyperledger. Here's a Fabric certificate account, and then you have a peer node, which is their local node running on their own server. In this case, this will be running on their AWS account, and they will be paying for that node. And then those will be connected via endpoint. These endpoint remains the same, which is the interface VPC endpoints. So as anything which is running within the AWS, you need to actually create a VPC endpoint so that external traffic can come and connect with it.
So, Anup,
Eh,
sorry to interrupt. Just a quick question. Are you sharing your screen because it is not visible to
Oh,
us?
sorry guys, my bad. I just stop at that point of time. Let me just, sorry guys, yeah,
Okay, no worries.
yeah, let me just go, yeah, sorry guys, yeah. So
Yeah,
this
it
I
is
was
visible.
talking, yeah. So I was talking about this Amazon managed blockchain service. So this currently the means initially how Amazon. So for past 2 years, I can see Amazon is playing a lot with blockchain. So initially they come up with uh, EC2 image, which you can actually deploy as a machine or as EC2. So initially they came up with Hyperledger and Ethereum. Then they came up for Coda. Now they discontinued it. Now this time they come up with a more, I would say, refined service, which is managed blockchain. So initially what happens like there is an image which is created, but then you need to actually set up the member service, the uh, certificate service all by yourself. Now, what managed services does it? They actually give you a cool interface and a cool APIs where you actually directly make few of the calls and your system will be set up. But beyond that, all your chain code will be outside of it. So you can actually deploy it, but again, that you can build it in the, I would say, Go language, which you are currently doing it, or the Java, whichever you prefer it, but that doesn't change it. So for that, you need to actually go through and learn the Hyperledger. If you are going for Hyperledger, if you are actually Ethereum, then something maybe Ethereum is currently not available, but I think maybe in couple of weeks Ethereum will be available, and the plan is to bring Coda also as part of the Amazon managed blockchain service. But currently, those products are not available. So people who are using Hyperledger, they can actually jump onto it, but those who are not using Hyperledger, they need to wait, I think. So this is the, I would say, structure of a Hyperledger, which is Hyperledger Fabric ordering service running on top of the members. So members has it their certificate authority and the peer node, which is their node running. So now in uh, AWS, what happens is these nodes are running on their own member account. Previously, what happens? You set up one image, then all other nodes has to set up their own nodes, and then you need to provide uh, the configuration keys so that those peer nodes start talking to each other. So I've done those kind of work previously, but now uh, with managed service, you can actually send an invite, and once the person accept it, then those configuration happens automatically. But the code and other thing, the DApps, has to be written the same way and needs to be deployed in a similar fashion. And the other layer is the interface VPC. This is this is the AWS community, so for anything which is running within that, when you want to expose it to the outside world for application to run or interact, you need to actually open those ports as part of our VPC endpoints for members to actually connect it, or the real world to connect with the digital world. So that's how AWS provides you. So let me just run a demo. Guys, and currently these services are, as means you guys know it. So generally these services means start with Ohio and Virginia, and these services still not available in Mumbai region. Go to Amazon Manage. So so this is like, so you can create a network, invite members, add peer nodes, deploy application. So this is like fully managed service provided by blockchain. But yeah, the coding and the smart contract and everything remains that of Hyperledger. So it's not something which is Amazon said, okay, we brought it, and you can write the or this is our blockchain. So if you are actually using Hyperledger, you can use it. But if not, you need to wait. So I will set up. Let me copy this because this is bit of a costly service. So request you, anyone who is playing with it, please delete it. So this is like voting policy for uh, any demo purpose or anything. You can keep it like 50. But again, it's like, what is it? So how it's those familiar with Hyperledger or blockchain. So anything, any changes comes as a proposal. And if you keep, or if you have not worked on it, you read the news about the crypto. So there is like, for any change in the Bitcoin or the crypto world, these are like came as a proposal, and then the community or all the nodes vote for that uh, change. And if they see, okay, this is the right proposal, agree to it, and if 50% agrees to it, and if you then that proposal will be made, and that code will be pushed into the blockchain. So this is a standard policy, but how there's like, okay, so this configuration part, Amazon encapsulated in a simple fashion. So if you are like, okay, want to make it 80%, you do it, uh, and that proposal duration is 24 hours. Generally, like, okay, proposal are open for 1 week, but again, uh, For this purpose, if it's a transaction and change, so those are also a proposal onto the blockchain. So those should not wait for 24 hours. But yeah, generally for enterprise and permission one, you just keep the proposal for 30% because, and you define the agencies. Just a second. Yeah, guys. So sorry. I just go ahead. Now, what is like so for any blockchain, because I was saying it's a distributed, there has to be a member. So, so I became the member, and then the admin member who can actually invite. I just you need to so keep it. Don't log in. Oops. Fine. Sorry, because never actually did this kind of work in my life. So, so now this is like one member is there, admin password. Okay, name is there, framework which I am. There is only one framework. Voting policy is greater than 30%. If 30% more, 30% agrees to it, then that proposal will be pushed onto the blockchain. Okay, so these are like pure concepts of, but how Amazon makes it simple. That's what I'm. So now I create the so this is so now it's creating a hyperledger instance on the blockchain for you. So currently there are like okay if you go. So once this is created, I can actually create a VPC endpoint from where my deep apps and the physical world or my apps can connect to this directly. Now I can actually invite a, I can create, because this is now still being created. Otherwise, I can create a peer node or I can invite the other members onto this chain. And here you can see all the proposal which other members can actually push, or if you have pushed it, any change, then those will be visible here on this. So this is like all primarily, and this is all your invitation currently because I think this is not coming because, oh, sorry, my this is getting created. It takes some time for to come up.
So, Amit, where is the integration of this blockchain and QLDB comes into the picture?
Uh, so so QLDB you can actually so what you can do is like so see it's a use case which is separate, right? But again, because QLDB is a structure is like of a blockchain, so you can pull this data from the hyperledger and deploy it onto the QLDB.
Okay.
So there once in the endpoint you can because once the endpoint you can say from a peer node you connect to the QLDB. So to be honest, I have still not tried it. What I have done it is like okay, I have currently deployed the Hyperledger and using the Hyperledger uh, framework and brought the network participants and running the peer node and the system via Amazon managed blockchain service and a QLDB for a separate use case. So which if someone is interested, so this is I have published an article on the Medium. So how we actually build it and picked QLDB as a right solution. But yes, there are how to actually currently pull the hyperledger data onto the QLDB, query it, or do the analytics on that.
Okay,
So we
fair
have
enough.
deployed smart contracts onto it, uh, but not the push the data from the QLDB, because this is primarily new and running all this is like bit pretty expensive. So we also need to kind of run the system, and then if it's not using, we need to close it and run it.
Okay.
Okay, so it's taking some time, but again, you can actually, the point was it makes the proposal and everything much simpler. So what used to take like 2 weeks to build it or set up can be done in like 5 minutes, and you have your blockchain network up and running in maybe in half an hour. Then what is required it if you are good in like if you are able to code, and if maybe you have coded your uh, on your own system, your smart contracts or chain code on the hyperledger, then making it productionize will not take months. Will might take like couple of days to bring it because of this managed service. Will go to the owner of that node. So that is also, or the other option which currently we are using is we are using kind of a concept which is an organization, which I think you part of the blockchain community or AWS community. So all our peers and nodes or members are part of the organization, so that we can see that what is the cost coming in, and jointly all the members pay for that network. So depend on what kind of solution or how your participants are. That is something which is very unique to the kind of the problem you are solving. If all your partners are willing to do it, then you can like, okay, I have a central billing, and from there everyone pay their part or do it. Otherwise, you can say, okay, in the kind of transactions you are doing it, uh, because if you are using a chain code, then of hyperledger, or let's say the channels of the hyperledger, then the costing for a node will be different for different participants. So then you might say the participant who are actually making more transactions then has to pay more, and someone who is not has to pay less. So those kind of is something which is very unique or different to your use case and has nothing to do with Amazon managed or the blockchain. So that's each one of you have to identify for yourself.
Sure, Anuj, fair enough. So,
So yeah,
what
that's
I can
taking some
assess,
time, but yeah,
sorry. So, what I'm saying, like, what I can assess from the
yeah.
comments and from the various discussions, that many of us have might not have actually practically worked on the blockchain. We have not done any hands-on around that. So, would you be able to suggest some links which we can go through, and we can really some explore some ready-made simple use cases with the help of Amazon, so we can try to run that and can try to run the concepts into reality, basically.
Okay, so for QLDB, yes, there are like a lot of use cases, and if I, that's why the current means what I have shown you guys is again when you create it, so because Hyperledger is not a blockchain product, so they don't provide it. But here, if you go, so here if someone wants to play with QLDB, everything blockchain, I would say AWS provides it. So you can load your sample data. Okay, how you query the tables, so that is defined. Modify the documents. So all these things is like okay, provided by the uh, AWS itself. So you can actually play with this. as a learning thing, as a first step, you can actually go by this example,
So
and then you
Anuj,
can relate.
again,
Yeah, yeah.
sorry, again, are you sharing your screen?
Oh, sorry, guys. I'm just sometimes. Yeah, this is bit okay because this never comes here. I just sorry. Yeah, sorry. I created. Let me just go back. So I was like talking about. So for QLDB, everything is, and so what I have shown you is, so you can create a ledger, go to QLDB, okay, and then you can actually load the sample data. So currently ledger is getting created, active now. So you go to go getting started, and then you can actually load a sample data to get your hand dirty with a little bit of coding and understanding it. And here you have all the details of how to query your tables. So these are like SQL queries, how you actually can query. So there is a concept which is a journal and a main. So where you put the uh, committed transaction to get the history of a particular transaction. So all these things are given here. Uh, Anyone who wants to play with it can use the same example, run these queries, and then you can create your own tables and run a use case. So for QLDB, yes, it's easy, but for Hyperledger, currently, if you ask me, is there a easy way to play with it? I said no, because you need to understand, because what AWS is, it's a cloud provider. So what is provided is like to give you an infrastructure of Hyperledger, but how you can actually start creating a smart contract and learning and building on it, still you need to go through uh, the Hyperledger documentation and try some use cases. Ethereum, I think, but currently Ethereum is not there. Just for the blockchain part, I'm saying uh, Ethereum provides a lot of ready-made use cases, which is provides a lot of use cases and which you can actually play, which is like maybe an effort of 1 or 2 days to build a voting system or another kind of systems. Yeah, developers start building. But currently, this is not available on. But who wants to learn? I don't know. I'm just visiting after maybe 2 3 years. But yeah, I built few of the initial. You copy the paste the code and start running. So as a first step, who wants to just work on Ethereum and maybe say that okay, they've created some kind of an application. This is the first step. I don't know why it is not loading. But yeah, if you guys wanted, I can uh, share the links with you guys. Hyperledger, I started long back, learned the hard way, and easy way to just from it, because it's like coming from the Linux foundation, and you know, uh, the documentation of the Linux foundation is primarily highly technology techy, and it's like so complex to so which makes it bit complex. Yeah. Oh. So yeah, I think maybe it's taking long, but yeah. Now this is like Studio Ethereum, so you guys can start Hello World Crypto
Sure.
Token.
Meanwhile,
So yeah,
meanwhile,
create a
maybe you can
project.
scan on the
Yeah,
questions which are there in the comment box. So
yeah.
maybe you would like to address them.
So so this is like the whole code is there. Deploy a token. Languages, certain validity. Your app is there. Contracts are there. So anyone who wants to just play with Ethereum, he can just start with it. So it could be a first step on a blockchain for someone. So these are like there are multiple lot of codes which are given already. So someone to just play with it. This has now changed a lot. But yeah, fine. Let me just scan through the questions. Yeah, guys. Any questions? Yeah, Blue Mix. Thanks. Uh, initially, they used to call it Blue Mix. No, 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 no. Okay, I'm just scanning through. Only read the concept. So, guys, maybe just for like, okay, thanks for your time. But again, uh, if you like the session and it's even like, okay, useful, can you just maybe say hi, hello, or something? Or if you have some question now, after the session, I'm happy to pick it up. Bank was taking a lot of time in the transaction, costly for money movement, also validation. We will be covering coding. Mayank, so yeah, so I think we will not be covering the coding part uh, because coding part is not as part of the infra. It's primarily the session is. I can do it on the Hyperledger, but again that will be not be primarily on AWS because the coding part will be a separate which you will be creating a chain code for Hyperledger. The only thing then the AWS will come is when you're deploying a code. But again, for that, I think people who are familiar with the Hyperledger will be able to connect. Okay, J, let's do it again. Complete example. Okay, thanks, Mayank. Got it, got it. Okay, now I can't answer. Understood till Sandeep, till where you told negotiation happened. I forgotten what I was talking and where I was talking about. Negotiation happened. Duplicate transactions got removed now. I don't get it. So I'm just trying to make okay. Okay. This is good. How QLDB is different than other standard DB. So if you make a standard DB read only, then see, so standard DB is controlled by you. So either you have to create a lot of audit logs, audit tables, but again you have a right to change it. But with QLDB, this is by design. This is append only and cryptographically secured, which can be validated. Okay, and if you make it read only, then how a new transaction will come on. So, and if I am controlling it, I have a control on it because it's admin control. I can actually override it and make the correction. And if I don't make a changes in the audit tables, then you will never be able to know that the change has been done. So maybe if you do take a simple RDBMS and build audit logs and changes logs and make it visible, available to someone, yes, that will make a QLDB. But again, for to do all those things and provide all those systems and running it on the cloud will take a lot of effort. But as like if you talk about any service on the cloud, you can actually set up your systems. But what uh, AWS does it makes it easier for you so that we can focus on a use case than to maybe the infra or the setup of those things. So I think under the hood, AWS must be doing the same thing. Okay. So yes, so for uh, QLDB, peer-to-peer and consensus doesn't happen. For I would say permission ledgers, generally the consensus doesn't happen. For or you can do it like via proposal, and you accept the proposal. That's for the consensus mechanism. Or you can say okay, but in public blockchain, the consensus has to be happened. Okay, distribution features, yes. Uh, So in pure public blockchain, there is 100% distribution, means all the nodes will get the transactions. But in like in Coda, the only the parties which are involved will get the uh, information of the transaction, and the notaries on Hyperledger. By default, everyone will get it, but via channels, you can restrict the people or the participant who will get the information. So let me explain why uh, broadcasting to everyone is not the right approach. So suppose I'm a bank which is having like 1 million transactions, and you are a fintech who has like 1,000 transactions. So now maybe, and you are just doing maybe 5 transactions. But if I am doing a 1 million transaction every day, then what is happening? If I'm broadcasting to everyone, then you as a fintech organization has to save all those transactions onto your node, which means you are doing only 100 transactions or 1,000 transactions per month, but you have to save 1 million transactions. And that's what I'm saying is you have to keep on saving those transactions for a longer time. That means you, uh, I would say, infra cost will be much, much higher than the amount of cost you are actually earning. So pure in blockchain it works because you just save a cryptocurrency very limit information. But when you are actually using a use case of a trade finance or a trading, then you are have a multiple information you are actually saving on a data, or I would say a blockchain. And if that start going or push to a new player, then they will actually run out of business just because of the infra cost. And that's why uh, distribution is not the right approach. And secondly, if me and you are participating and agreeing, then why the third party needs to actually save the data if we both are agrees to it? So again, this is like use case basis. There is no right and wrong answer to those things. Dipali, I answered yours is like how to create smart contract. So smart contract is generally you don't create it because it's infra for Hyperledger. So you create your smart contracts on the Hyperledger. Once the Ethereum will come, you will create it on the Ethereum. There is no offering as such on AWS. So nothing changes and nothing special about Hyperledger. How blockchain can be used in network security or blockchain. This is a use case which I need to think through. Currently, I don't have an answer how for network security. Is QLDB only AWS related to? No, there is managed service which I already like shown about. I want to know and practice about blockchain. How can I start learning? So yeah, I've shared you a couple of resources, shown you. You can start with first with Ethereum or QLDB and then move on. So yeah, there's no other question left. So if there's anything, then fine. You can guys reach out to me. I will share the pack to Deepali, and Deepali can push it to the community. or you can actually reach out to me via LinkedIn. So
Sure, Anuj.
that's all
Thank
from
you
my
very
side.
much.
Yeah. Thank you.
Yeah,
Thanks for your time, guys. It
thanks.
was
Good,
great.
a great
Yeah.
of the concepts. But yeah, I think at this stage we need to explore a little more so we can better connect the dots basically. But yeah, thank you so much for the good food for thought.
Yeah.
At least now we have some courage to explore more in the blockchain area.
Yeah, definitely. So what currently as part of highlights, what we run is like, okay, people who are interested can actually join our working teams, but who are like committed. So we are working on few products and we also have some hence. So if people are committed and willing to commit like few hours, then happy to join offer. Cheers. Take care. Thanks for your time. Great.
Thank you very much, Anuj. Thanks everyone for your time.
Thanks.